Here we consider the use of conversion factors in chemistry. There are a number of approaches to calculating quantities in chemistry. The most common is the conversion factor approach. This is sometimes called the factor label method or dimensional analysis. The bottom line is that we will convert from one quantity to another using what is called a conversion factor. Let's try two examples that deal with measurements you should be familiar with. For example, I'm 6 feet tall. What is my height in inches? You might just say multiply by 12 and get the answer, but actually you did something more complex. You read the problem and saw that it asked you to convert from feet to inches. Then you took a standard measurement, 1 foot, and asked what is in 1 foot. Then you did the algebra, starting with the number given in the problem and multiplying by a conversion factor. The conversion factor was constructed from the two equivalent amounts, placing feet in the denominator and inches in the numerator. Algebra on the numbers, 6 times 12 divided by 1 gives 72. Algebra on the units, feet times inches divided by feet, shows feet canceling, giving inches. The fraction 12 inches divided by 1 foot is called a conversion factor. In any conversion factor, the numerator and denominator are equivalent amounts. In this case, 12 inches and 1 foot are the same length. Multiplying by a conversion factor changes the number and the unit, but not the actual length. I did not get taller or shorter on going from 6 feet to 72 inches. Here is another example that asked, how many liters are contained in 165 milliliters of liquid? We'll use our three skills, reading, chemistry, and math. Reading the problem shows we need to convert from 165 milliliters to liters. For the chemistry, we know a standard volume measurement is 1 liter, so we ask what is in 1 liter. There is, of course, 1 liter, but also 1,000 milliliters. For the math, we start with the number we are given, 165 milliliters, and construct a conversion factor with milliliters on the bottom so they cancel out, and liters on the top. The answer is then 0.165 liters. In summary, using conversion factors is a standard method in which we can express a measurement in more than one unit. To construct a conversion factor, we read the problem to determine what units are being converted, we express the equivalent amounts in those two units based on a known standard, and we constructed the conversion factor such that the original unit canceled. This three-step process will be useful in many applications in chemistry. When quantifying elements and compounds, the standard amount will be 1 mole of that material.